Have you ever stopped to think about how many planets exist beyond our solar system? Imagine giant worlds, bigger than Jupiter, or small, mysterious ones, orbiting stars so distant we can barely see them. These exoplanets might hide secrets that could transform everything we know about the universe. What might we discover out there? And more importantly, how can we find these invisible worlds? Stay with me, because in the next few minutes we're going to delve into the mysteries of exoplanets and what makes the search for them so fascinating. What is an exoplanet? An exoplanet is a planet that doesn't belong to our solar system, but instead orbits another star. To understand this, think of the Sun as our giant lamp in space, with the familiar planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, orbiting around it. These are our local neighbors in the vast cosmic backyard. Now imagine you're gazing at other stars in the night sky. Each of those stars could have its own set of planets, but because they're so far away, we can't see them directly. When we discover a planet like this, one that orbits a star outside our solar system, we call it an exoplanet. Exoplanets come in all sizes and types. Some are larger than Jupiter, others are smaller than Earth. There are gas giants that resemble the giants in our system, and there are rocky planets that might remind us of our own world. Many are very close to their stars, their surface is boiling hot. Others are farther out, frozen in extreme cold. And in some rare cases, we find exoplanets at just the right distance, where liquid water might exist. When scientists study exoplanets, they aim to answer some important questions. Are there other planets similar to Earth? Could there be places where life might exist? Studying exoplanets helps us understand more about how planets form and evolve, and it reminds us that the universe is far larger than just our own solar system. How do we know they exist? Discovering exoplanets is like trying to spot a firefly next to a bright lighthouse. Stars are incredibly bright, while exoplanets are small and don't emit their own light. This makes seeing them directly nearly impossible, especially given their vast distances from us. So how do we know they're there? Astronomers use clever techniques. One of the most common is observing the light from a star and looking for tiny, regular dips in its brightness. Imagine watching a theater play and someone briefly walks in front of the spotlight. For a moment, the light appears a little dimmer, right? When an exoplanet passes in front of its star, it creates a similar effect. This is called a transit. Another way to find exoplanets is by watching the star's movements. Even if we can't see the planet directly, we know it also exerts a small gravitational pull on its star. It's like a very enthusiastic dog tugging on its owner's leash. The star wobbles slightly as the planet orbits around it. With highly sensitive instruments, scientists can detect these tiny movements. These two techniques, observing transits and stellar motion, have already helped us find thousands of exoplanets. They provide clear evidence that even if we can't see these worlds with our own eyes, they are indeed out there, orbiting distant stars like a vast treasure hidden in the universe. Why do we use special telescopes? Finding exoplanets isn't as simple as just pointing a regular telescope at the night sky. The main challenge is that the light from the stars they orbit is extremely bright. Even a planet the size of Jupiter looks minuscule and nearly invisible compared to the intense glare of its star. It's like trying to see a candle on the other side of a stadium flooded with spotlights. To discover exoplanets, we need special telescopes, some of which are placed outside Earth. In space, away from our planet's atmosphere, telescopes have a much clearer view. On Earth, air distorts the light from stars, creating what we call twinkling, the sparkling effect we see with the naked eye. But in space, there's no atmosphere to interfere. Telescopes like Kepler and TESS are designed to orbit above Earth and monitor the brightness of hundreds of thousands of stars simultaneously. These telescopes are incredibly sensitive. They can detect tiny variations in a star's light, such as when an exoplanet passes in front of it. Moreover, space telescopes have cameras and sensors specially made to capture infrared signals and other wavelengths that are invisible to traditional telescopes. Thanks to these instruments, we've discovered that exoplanets are far more common than we once imagined. We now know that almost every star has planets orbiting it. Space telescopes have also revealed fascinating details about many of these worlds, including their sizes, masses, atmospheres, and even hints of their compositions. Even though we still can't directly see most of them, these special telescopes serve as superpowered eyes, allowing us to view the universe with a precision and clarity that was once unthinkable. Looking for subtle movements. Even if we can't directly see an exoplanet, it still leaves intriguing clues for scientists. One of the most fascinating ways to find these distant worlds is by observing how they make their stars wobble. That's right. An exoplanet, despite being much smaller than its star, exerts a gravitational pull on it. This force causes the star to move slightly. Not something we can notice with the naked eye, but something detectable with extremely precise instruments. Think of it like a swing. When you push someone on a swing, they go forward and backward. Now imagine you're very small compared to the swing. Even so, each time you push, you feel a slight jolt backward. Something similar happens between an exoplanet and its star. As the planet orbits, it slightly pulls its star. This causes the star to move back and forth at a steady rhythm. Astronomers use instruments called spectrographs to measure this dance. When the star moves, the spectrograph detects changes in its light. If the star's light appears to shift a little toward blue or red, something known as the Doppler effect, it could indicate that it's wobbling due to the presence of an exoplanet. Using this technique, known as radial velocity, scientists have discovered hundreds of exoplanets. Even without seeing the planet directly, these measurements reveal its existence, pulling its star like an invisible string. So, while these movements are very subtle, almost like whispers in the universe, these small signals tell big stories about worlds beyond our visual reach. Searching for special light signals. Even when we can't directly see an exoplanet, it may leave clues in the light coming from its star. These clues act like fingerprints. When a star's light passes through an exoplanet's atmosphere, if it has one, some of the planet's gases absorb certain parts of the light. This creates unique patterns that scientists can identify. Imagine the star's light as a large rainbow. Normally, this rainbow includes all the colors together, but when it passes through a planetary atmosphere, some of those colors disappear, as if someone erased certain lines in a drawing. These erased lines aren't random. They depend on what's in the planet's atmosphere. If there's water vapor, carbon dioxide, or methane, each leaves its own distinct mark. Astronomers use sensitive equipment, like spectrographs, to break apart the star's light into all its colors and look for these special signatures. Sometimes, light from an exoplanet can also reflect off its surface or clouds, offering more clues. With this information, scientists can say incredible things, like whether a planet is enveloped by a thick layer of gases or is a drier, rocky world. These light signals not only help confirm that the planet exists, but also teach us more about it. We can learn if it has elements vital for life, such as water, or if its atmosphere is toxic and inhospitable. It's almost like looking at a glass of juice and figuring out what it's made of just by noticing the colors and smell. In this way, even without visiting these worlds, we can begin to imagine them and understand what they might be like. Different sizes and types of planets. Exoplanets are incredibly diverse, with characteristics that go far beyond what we find in our own solar system. There are giant planets, even larger than Jupiter, that could swallow dozens of Earths. Others are smaller, almost the size of Mars, and have surfaces that may be solid and rocky. It's like opening a box of surprises. You never know exactly what you'll find. Some exoplanets are known as hot Jupiters. These are giant gas planets that are incredibly close to their stars. They orbit so quickly that an entire year on these worlds might last only a few Earth days. Due to their proximity to their star, their temperatures are extreme, exceeding 1,000 degrees Celsius. In contrast, there are planets very far from their stars, frozen in extreme cold, where the light is just a faint glimmer in the sky. Other exoplanets defy our imagination. Some are so low in density that they seem made of foam, while others are so dense that they must be composed almost entirely of iron. Some may even be mostly made of water, creating endless ocean worlds. Then there are planets with thick atmospheres and clouds of exotic compounds, like crystals or liquid metals. This variety shows that the universe is far more creative than we thought. Each exoplanet offers an idea of how planetary formation can differ in other parts of the galaxy. That's why when scientists find a new exoplanet, they not only confirm its existence, but also study its size, composition, and type. It's like collecting pieces of a giant cosmic puzzle. By assembling these pieces, we gain a better understanding of how planets are born, evolve, and perhaps where we might find conditions similar to those on Earth. Why is it important to find exoplanets? Discovering exoplanets helps us answer fundamental questions about our place in the universe. Knowing that planets orbit other stars confirms that our solar system isn't unique. This makes us reflect on how these worlds form, evolve, and arrange themselves. Is Earth a special type of planet or just an ordinary example? Studying exoplanets also fuels scientific curiosity. By analyzing their atmospheres and compositions, we can learn how they differ from or resemble what we already know. This provides clues about which conditions might support life, or even how life could exist on entirely different worlds. Furthermore, exoplanets inspire us to dream about the future. They make us imagine a day when we might explore other star systems, searching for resources or even new homes. While that vision is still distant, each discovered exoplanet brings us closer to that horizon, expanding our understanding of the cosmos and the possibilities beyond our solar system.